This is Pushpa here from Modern English High School. Today we will study Standard 8 Science, Lesson 12 Friction. The force that opposes the relative motion between two objects in contact is called friction. The force of friction acts on both the surfaces. The force of friction always opposes the applied forces. Students, just see the figure 12.1. A boy falls down when he steps on a banana peel. It is difficult to walk on a smooth, wet floor. Next, when brakes are applied, vehicle slows down. Any object moving over the surface of another slows down when no external force is applied on it. A moving ball stops after moving on the ground for some time. From these examples, we can find that it is opposing force that stops the moving object. Let us study some causes of friction. Friction depends upon the surface of the objects, or for a given pair of surfaces, friction depends upon the state of smoothness of those surfaces. Friction depends on how hard the two surfaces press together. No surface is perfectly smooth. The surface has some ups and downs called irregularities. When an object is moved over another, these ups and downs interlock with each other, giving rise to the force of friction and thus opposing the motion of bodies. In above examples, the more the regularities, more is the friction exerted. For a smooth surface, less friction is exerted, and for a rough surface, more friction is exerted. Refer activity 12.1. In case A, we are pushing a book which is kept on a table. The book moves and stops after some time. When we repeat this activity by giving a push in opposite direction, the book moves and stops again. Here the force acting on the book opposing the motion is force of. If we apply force along left, friction acts along right. If we apply force along right, friction acts along left. So we can say that the force of friction always opposes the applied force. Force of action acts between the surface of the book and the surface of the table. Let us learn about factors affecting friction. The first factor is the nature of the surface. If the surface is smooth, less friction is produced, and if the surface is rough, more friction is produced. Let us understand this with the example. Refer the figure 12.3. A brick being pulled by a spring balance. Now see the picture of spring balance. Let us understand about this. It is a device used for measuring force acting on an object. When a force is applied, coiled spring is stretched. The stretching of spring is measured by a pointer moving on a graduated scale. Graduated means markings which are given on the device, such as 1 kg, 2 kg, etc. Now, the reading on the scale gives magnitude of the force. Continuing with the activity 12.3, a brick is being pulled up by a spring balance. The brick is in contact with the floor. Due to the irregularities on the surface of brick, force of friction will be more. Say for example, it is 1.5 kg. Now wrap a polythene around the brick and repeat this activity. Now students, as polythene is around the brick, the area of contact is between polythene and the floor. As polythene is smooth, force of friction exerted will be less. When we pull the brick by a spring balance, reading will be less. Say for example 1 kg. This is because smooth surface, less friction is exerted. Now again repeat the activity by wrapping a piece of jute around the brick. Now the surface of contact with the floor is jute, which is more rough than brick. Friction exerted will be more. Say for example 2 kg. The reading on the spring balance will be more, so this proves that the nature of surface affects friction. Now coming to 12.3 activity. Make an inclined plane on a table using a support. Mark point A on the inclined plane. Let a Pencil cell move down from this point. Now see the figure 12.4. In case A, the pencil cell moves to a long distance on the table. Note the distance. Now as shown in figure 12.4b, spread a piece of cloth. There should be no wrinkles. Again, let the pencil cell move down from point A. This time, the distance covered will be less than before. If we repeat this activity by spreading a thin layer of sand over the table, the distance covered by the pencil cell will be very less. Why does this happen? The smoothness of the surface increases or decreases friction. The table was smooth, so the distance covered by the cell was more, and as force of friction was less. Whereas in case of piece of cloth or in case of sand, the distance covered was less as the friction exerted was more. Now friction is caused by the irregularities on the two surfaces in contact. Smooth surfaces also have large number of irregularities. Refer the figure 12.5. Irregularities on the two surfaces lock into one another. To move an object on a surface, force applied has to overcome interlocking. Rough surface has more irregularities, so the force of friction is greater. Smooth surface has less irregularities, so the force of friction is less. So, the irregularities seen on the surfaces depends how much friction will be produced on each of the surfaces or each of the objects. The second factor is weight. The weight of an object is more, the friction is more. If weight of an object is less, the friction is less. Example, it is easier to drag a mat when nobody is sitting on it. But when a person is sitting on it, it becomes difficult to drag because due to the weight of the person, friction increases, so we require more force to drag the mat. The third factor is the surface area and contact. Example, a small box is easier to be pushed than a big box. A big box has large surface area, the friction exerted will be more, so it is difficult to move the box. Secondly, the small box has less surface area, the friction exerted is less, so it is easier to move it. Now students, we come to the types of friction. The first is static friction. The friction which comes into notice when the body is just in contact with other body but there is no relative motion. It is static friction. Example, a wooden box kept on the floor is at rest. It is in contact with the floor but there is no motion of wooden box. Such type of friction is called static friction. Or the force required to overcome friction at the instant an object starts moving from rest is a measure of static friction. The second type of friction is sliding friction. It is the friction offered when one body slides over another body. Example, if a boy is sliding on a slide, the friction is between the boy and the slide. We can say that the force required to keep the object moving with same speed is a measure of sliding friction. Refer the figure 12.6. As the boy is pushing the box, it starts sliding on the floor. It does not get enough time to lock into the contact points on the floor. So sliding friction is slightly smaller than the static friction. So it is easier to move the box which is already in motion. Friction is necessary for many of our activities. A glass tumbler whose outer surface is oily becomes difficult to hold if there is no friction. It is difficult to walk on wet muddy floor. We are able to walk due to friction. Refer the figure 12.7. A nail fixes into the wall due to friction, otherwise it will slip from the wall. We can write with pen or pencil only because of friction. A teacher writes with a chalk on the blackboard due to friction. Some chalk particles stick to the blackboard due to friction between the chalk and the board. It could not have happened without friction. A moving object stops due to friction. A moving ball will go on moving if there is no friction. It is the friction between the ball and the ground that makes it stop after some time. In case of vehicles or automobiles, it is the friction between the tire and the road that makes them start, stop, or turn to change the direction. In order to start a vehicle, the tire has to come into contact with the road. Due to friction between the tire and the road, the vehicle starts, stops, and turn to change the direction. Tires make grip with the road. Then only they can move. Even for changing the direction, tires have to stop for some time and then move. If there is no friction, this will not be possible. When we are walking, it is the friction between our foot and the road that makes us walk. So friction is necessary for us to walk also. Next example is tie a knot with smooth thread. Smooth thread shows less friction. So if we tie a knot, the knot does not remain for long. Whereas if we take a rough thread and tie a knot, due to friction, that knot remains for long. Next, the steps of foot over bridge gets worn out. This is because many people must have used the steps. Due to friction, the steps were becoming worn out. Now students, friction also produces heat. See the figure 12.9. Rub your palms vigorously. We feel warmth. Friction between two palms produces heat. Next example is when we strike a matchstick against rough surface, it catches fire. See the figure 12.10. Due to friction between the matchstick and the rough surface, the matchstick starts or it catches fire. Next example is when we start a mixture, after some time the jar of the mixture becomes hot. This is due to friction. Due to the heat generated, there is much wastage of energy. Let us discuss the ways of minimizing friction in the next. Friction is necessary in our day-to-day life. Let us learn the ways to increase or decrease friction. Friction is desirable in some cases and undesirable in some cases. Let us discuss some examples. First is, the soles of shoes are grooved so that the grip between shoes and the ground should be there and chances of our slipping on the ground reduces. Second is, treaded tires of car bulldozers. They also provide better grip on the road. See the figure 12.11. Friction is used in brake system too. When we apply brake, the motion of wheels stops and the bicycle stops moving. Third, kabaddi players rub their hands with soil for better grip of their opponents. Gymnasts also apply some substances on their hands for better grip. In some cases, we want to minimize friction. Let us study some examples. We sprinkle fine powder on carom board. You all must be playing it. Due to this, surface of carom board becomes slippery and friction reduces, so it becomes easy to strike. Next, we pour oil on hinges of door because due to friction, movement of door was difficult. But when we apply oil, friction reduces and smoothness increases, so the movement of door becomes easy. Next example, a mechanic uses grease between moving parts of machines like bicycle chains, different machine parts, etc. They get worn out due to friction of the different parts. Materials like oil, grease, graphite increases the efficiency of the machine as it reduces friction. A thin layer is formed there and moving surfaces do not directly rub against each other. So movement becomes smooth. Movement becomes smooth as interlocking of irregularities is avoided to greater extent. See the figure 12.13, how the lubricant works. The substances which reduce friction are called lubricants. Some machines it is not advisable to use lubricants. It differs from machine to machine. In this case, the air cushion is used between the moving parts to reduce friction. So air is used as lubricant here. Now if you are using large amount of lubricants or if you are polishing the surface, can friction become zero? No, it is not possible because we can reduce friction but it cannot become zero as machines will not work, so it cannot be eliminated. Now how wheels reduce friction? Let us study about this. See the figure 12.14. A small boy can pull a trolley bag easily because wheels are put on it. We can drag the luggage easily. To understand this, see the activity 12.4. Take pencils having cylindrical shape, place them parallelly on a table, place a thick book on them. Push the book. Pencil starts rolling and the book starts moving. Due to pencils, the friction between the book and the table is reduced. It becomes easier to push the book kept on the pencil than if it is kept on the table directly. Wheels have reduced the friction which was between the table and the book. Heavy objects are moved by using some objects having wheels. When one body rolls over the surface of another body, the resistance to its motion is called rolling friction. Students, we have already studied about static friction, a friction offered when an object is at rest, that means which is not moving. A friction between the object and the ground. So this friction is static friction. Next is sliding friction. When one object slides over another, the friction is called sliding friction. Now when an object rolls on surface like wheels, such friction is called rolling friction. Due to rolling, the friction is reduced. It is easier to roll than to slide a body over another. Rolling a book on wheels on a table is easier than sliding a book on a table. Thus, it is convenient to pull the luggage fitted with wheels. So, wheels are one of the best invention of mankind. In many cases, sliding friction is replaced by rolling friction in most machines by using ball bearings. In ceiling fans and bicycles, ball bearings are used between hubs and axles to reduce friction. Now we can see that in figure 12.16. Next we are going to study about fluid friction. What are fluids? A term used for gases and liquids is fluid. It has no fixed shape. Air is light. When we walk in one direction, air exerts friction on us. It exerts frictional force on objects moving towards it. If we are walking against the direction of air, it exerts frictional force on us. A swimmer swims against the flow of water in the river. The water exerts frictional force. Swimmer has to work hard to overcome the frictional force. But if he is swimming in the same direction of the flow of water, then he will experience less friction and can easily swim in the river. Liquid and air both oppose the object moving and limit their speed. This obstruction is fluid friction. Density of liquid exerts frictional force. A dense liquid exerts more friction. Seawater is salty, so to move in the seawater it becomes difficult as more friction is exerted by salty water. So we can say fluids exert force of friction on objects in motion through them. Frictional force exerted by fluids, also called drag. Let us learn about the factors on which a frictional force in an object depends. The first is the speed of an object. If the speed is more, the friction is also more as it comes in contact with many things. Second is the shape of an object and nature of an object. To minimize friction with fluid, body must have streamlined shape. Birds, fishes, etc. they move comfortably at the same required speed due to this shape. Next is nature. More density, more is the friction seen. When objects move through fluids, they have to overcome frictional force acting on them. While doing so, they lose energy. Efforts are therefore made to minimize friction. Nature has made them such that they are able to overcome friction and move along. Birds can fly in air due to their body shape. Fishes can swim comfortably due to their streamlined shape. Boats, aeroplanes are given the shape of bird, which helps in overcoming the frictional force. So this is all about how the frictional force is reduced. Next we'll see next chapter. Thank you.